Konnichiwa, Marcellino sensei. I, Felix, and my friend
Farhan.
will present about.
COVID-19 exponential growth in Indonesia.
We want to explain about exponential growth and prove that the COVID-19 growth in Indonesia for a certain period of time is exponential. With this presentation, we hope that we can also increase the awareness of the pandemic and decrease the rate of the spreading of COVID-19 virus. First of all, what is an exponential growth graph? An exponential growth graph is the quantity that increases with a rate of proportional to its current size. It is normally deduced in an equation of fx equals to a times 1 plus r with the power of x. This is the example of an exponential growth graph. It is very different from a linear growth graph, which is a straight line. Exponential growth graph makes a curve which goes upwards direction.
So a common application of exponential growth is the R naught, or the reproduction number of a virus, that will be somewhat related to the presentation. So if you can see the picture on the left, this illustrates a virus that has an R naught of 2. So here, patient 0, or the first ever patient that suffers the virus, will infect 2 people. And these 2 people will then infect another 2 people, and so on. So you can see that initially the spread is not that much, but as time goes and the more people are getting infected, the growth will be dramatically increasing, and this is an illustration of exponential growth. And on the picture on the right, you can see that these are some of the reproduction number of several viruses like Ebola, MERS, polio, and SARS-CoV-2. And as you can see here, the virus of measles has a reproduction number of 12 to 18. So it means that each people can transmit to another 12 to 18 people. So in this case, for SARS-CoV-2, since it's a new virus, scientists are figuring out that it's around 1.5 to 3.5. So it means that people who is infected with SARS-CoV-2 can possibly infect around 1 to 3 people. So the current situation of COVID-19 in Indonesia is very severe. And as of 28 February 2021, we have 1.3 million confirmed cases with 35,700 deaths, according to the World Health Organization. And for this presentation, we would like to focus on the time frame of November 2 until January 31. And you can see it on the highlighted bar graphs. And we believe that during this period, the confirmed cases is growing exponentially. And we'd like to illustrate it on this presentation.
This is our data. Our data is taken from 2nd of November 2020 until the 31st of January 2021. We choose to present the data in a weekly basis. The number here is the daily increase in the time frame of 7 days or 1 week.
So we are going to model our data with Blake van Berlo's exponential model. So he is a mathematician that initially modeled Canada's COVID-19 cases with the above equation, the exponential growth equation. And with this equation, we can predict that and conclude that if the COVID-19 cases continue to follow the equation above, or exponentially, this shows that the growth is exponential and the increase of COVID-19 is going to be very, very rapid. And we're going to prove the data above that we gathered with this equation.
The exponential graph above is drawn using an online graphing calculator called Desmos. To draw this graph, we just need to put the weekly data from before into the table in Desmos. Based on Blake van Berlo's exponential model, we can deduce that the equation of this graph by y equals to 1.4 e with the power of 0.175 times x plus 10 plus 16.6.
So the way we derive the graph and equation is using Desmos. And as you can see here, with the Blake van Berlo's equation, we have 4 different constants that we can manipulate, which is A, B, C, and D. And after many trials and errors, we can finally conclude that With the data that we have gathered, the appropriate constants for A, B, C, D are as the following. So 1.5 for A, 0.175 for C, -10 for D, and 16.6 for B. And from the trial and errors, we found out that these constants actually affect the graph with different effects. So for example, we found out that A, in fact, it affects the steepness of the graph. And for B, it affects the horizontal asymptote of the exponential graph. And for C itself, it affects the width and the sharpness of the graph, similar to A, but not as drastic as A. And for D, it basically shifts the graph to the right and left. So from the graph and the equation that we have derived, we can conclude and prove that COVID-19 in Indonesia is indeed increasing exponentially during the time frame of November 2 until January 31. And throughout our analysis, we have found out that there are specific incidents and non-specific factors that led to the exponential increase of COVID-19. So for example, in November and December alone, there are several long breaks and holidays that led to people going back to their hometowns and vacations. For example, is the long break of Christmas and New Year, and we can see that there are an increase of people going back to their hometowns throughout these period. And also, there are specific incidents like the one in Petamburan in Jakarta in November, as you can see here from the news that we displayed on the slides. And this specific incident led to the emerging of newer COVID clusters in Jakarta. And also, it's also proven that during this long break here, from a news in 7th of January, after the long break holiday, COVID-19 cases increased until 49% of the ICU is almost full in Jakarta alone. And non-specific incidents or events that led to the increase of COVID-19 exponentially, for example, is the low number of COVID-19 tracer that Indonesia has. So apparently we only have less than 5,000 COVID-19 tracer. And for your information, COVID-19 tracer are people who trace COVID-19 cases in the community. So it's very important to do contact tracing to find out who is in contact or is susceptible to the virus itself. And again, because the COVID-19 cases is infecting doctors and nurses, the number of healthcare workers also decreases because unfortunately some of them succumbed to the disease that they died. And unfortunately, so yeah, we're lacking the number of doctors and nurses as well. And also other factors is the PSBB alone. And according to some epidemiologists and experts, the PSBB is not very effective in mitigating the pandemic because it's not very strict and they don't really have stringent policies. So people are still, even though the PSBB does not encourage people to go out, but since there's no strict policies, people still have the audacity to go out of their homes and so on. So yeah, so these are some of our analysis that also contribute to the exponential increase of COVID-19 cases in Indonesia.
In conclusion, we should do social distancing and we should wear masks every day if we want to go out. And also, in the current pandemic, we should avoid daily activities such as meeting people and going to crowded places. We should also avoid traveling and going out since the current pandemic is spreading exponentially. Thank you everyone for watching. We hope that with this presentation, we can give you more information about COVID-19 from a mathematical point of view. Bye bye. Wir sind Jäger.
Wir sind Jäger.